At multiple times throughout this course, I've reminded you that the syntax we've been using is for Microsoft SQL Server, and it can differ for other relational database management systems. So I want to give you a really basic example of what I mean by that. Let's take two database servers. So SQL Server, being the one that you're probably most familiar with after this course, and MySQL, another enormously popular database server. Now let's take an example. In SQL Server, if we want to grab the top 5 records from the widget table, we would run this query. Pretty straightforward. We've seen that already in this course. However, in MySQL, it'd look like this. So only a very minor difference. Instead of a top 5, we've got a limit of 5, but obviously also in a different position in the query. Now this is really important because they won't interchange. We can't run a top 5 star against MySQL, and we can't run a limit 5 against SQL Server. So establishing what the database server is a really critical step to mounting your attacks, because you've got to make sure you're running the right syntax. We'll have a look at how to discover that in just a moment. Now this is just one very simple example, but I want to show you a more comprehensive list of differences. Firstly, so that you appreciate just how much variance there is between database servers, and secondly, so that you've got a good resource to go to when you need to figure out how to construct your attack. Let's take a look at that now. There are plenty of resources on the web that explain the language differences between different database servers. The reason I'm showing you this one is because I like how comprehensive it is, and it gives you some great examples. So as I page down through this list, you'll start to get a sense of just how complex this topic can be. And in fact, what I want to do is just page down to one example, and it's this one, inserting several rows at a time. And what you'll see as we scroll down a little bit further is a good example of the variances I'm talking about. So let's take this syntax just here. Now you could take this syntax and you could use it against Microsoft SQL Server, but only if it's SQL Server 2008 or newer. You could use it against MySQL, and that's fine, you'd get away with that. But then you couldn't use it against Oracle because, as they say here, there is an Oracle-specific kludge of this implementation. Now that's just one very simple example, and you can get a bit of a sense by how much stuff there is on this page just by virtue of the fact that we've only scrolled about a quarter of the way through it. Now the thing with this here is it shows us that not only are there differences between database management systems, but there's also differences between versions. So that SQL one is a perfect example. If you're using SQL 08 or newer, you can use the syntax. If it's earlier, and there is still a lot of stuff out there that's earlier, then it simply won't work. As we progress through this module, you'll also see some semantics about the SQL implementation on our sample vulnerable website. That's running in Microsoft's Azure SQL database implementation, and that has its own semantics as compared to the full-blown SQL Server instance that you'd run on, say, an on-premise installation. So again, understanding the versions is really important. So let's jump over to our sample vulnerable site, and I'll show you how to find the version of the underlying database. So back on our sample site again, let's jump back down to those engine capacities. We'll grab the V12s again, and we know that we can inject using error-based injection right at the end of this query. So let's do this. We'll close off the V12, and I'll add a statement here. And 1 equals at version, and we'll comment out everything after that. So let's run this and see what we get. Now, as we know already, that equivalency with the number 1 is going to cause a typecast exception. And consequently, the error-based SQL injection risk on this page has returned the internal database version. And it's everything from here down to here, even including line returns. So we can see here that it is running on Microsoft SQL Azure 12 point something. And in fact, this version was updated on April 15 of 2015. So we now have some very, very specific information about what this version is. Now that we know that, we can tailor our attack and make sure that we're actually using SQL Server syntax and not Oracle syntax or MySQL syntax. Now, having said that, whilst this discovery is important, you can often make pretty educated guesses about the underlying database system. So if you're looking at Microsoft technology, so for example ASP.NET, and you can tell that via either response headers, page structure, or even file extensions, there's a high probability it's going to be running on Microsoft SQL Server. If you're looking at the LAMP stack, so for example PHP running on Apache, and again you can tell this from response headers and page structure and other common telltale signs, you're probably going to be running on MySQL. So even when that internal version isn't immediately discoverable in this way, you can usually make a pretty educated guess. A notable exception that has been emerging in recent years, though, is the rise of NoSQL databases, CouchDB, MongoDB, RavenDB, and other data constructs such as Microsoft Azure's table storage. There are many more implementations today that aren't queried using SQL syntax than what there were just a few short years ago. So just be conscious that even if you are looking at a data-driven website, that doesn't necessarily mean there's a database underneath that may be exploitable via SQL injection. So keep that in mind as well. With that said, let's now move on and start to have a look at how we can discover more information about the internal implementation of the system.